And remember, I had used the term flood control. So, and I told you that I'll come back to it. So, basically, flood control, although it used to be used quite regularly earlier, now I think there's a general philosophy towards appreciation of natural resources as not something we control, but something that we harvest and something that we live with. So the word flood control, the term flood control, uh, I mean, there's a better alternative these days, and that's called flood risk management. All right. Okay, now let us look at some pictorial representation of all the things and concepts that we discussed, because they say a picture is worth 1,000 words. So let's look at first. So this structure that you see here, this is the Hoover Dam, the very famous Hoover Dam. That's in the border of the two states of Nevada and Arizona in the United States. So it's an engineering marvel. It's a huge structure, and it supplies hydroelectric power to quite, I think, several million people actually. And you can actually watch very interesting videos and how it was constructed. So the Hoover Dam is on the Colorado River, and the Colorado River, as far as I remember, it flows through almost 5 to 7 states in the United States and also in Mexico. And like the Indian rivers, which are where you have riparian treaties where the water is shared between states and countries, the Colorado River also supplies water, and the Colorado River water sharing is one of the most exemplary water treaties in the whole world. So let's see the different parts and components of the Hoover Dam water resources system, which are relevant for our course. Uh, but before that, in the popular culture, the latest I remember seeing the Hoover Dam was in a, well, not so very impressive movie, which is called Dhoom 3. And this guy that you see right here is Amir Khan trying to do the stunt. So this is the concluding sequence. Not exactly the concluding, but the the pre-concluding sequence where the twin brothers actually die by jumping off the top of the dam. So here is Amir Khan shooting in the Hoover Dam for Dhoom 3. And not just this one, you may have seen the Hoover Dam in several. It's quite prevalent in popular culture, and you might have also seen it in other movies and series and so on. So now let's try to appreciate the Hoover Dam from a hydraulic engineer's perspective. Okay, these two that you see here are the intake tower. These are the intake structures. This is where the water is taken in. And one of the most important purposes of the Hoover Dam is hydroelectric power supply. It has a penstock, which is, you will be able to appreciate the penstock right here in this cross-sectional diagram. So these are the intake structures that we saw, and you have the penstock. Let me, yeah. So this big pipe that comes here, these are the penstock. This comes to the turbine into the powerhouse, and the Hoover Dam also has spillways that are also in the form of tunnels. So you have let's see in the plan. I think you will be able to see the so this is the Arizona spillway. So that's one of the most important spillways of the Hoover Dam. Again, spillway is a structure which is used to dissipate to release excess water, and excess water comes with a lot of energy. So below the spillway you will have to dissipate the energy of these gushing waters. This part that you see here, this is called the stilling basin. This is where the hydraulic jump forms. And what else? So that's the dam. This is the powerhouse, and these are the penstocks. So these pipes that you see here, the long ones, those are the penstocks. And let's see how penstocks in general look. So you see the particularly this one, you see this is also underground, and the pipes are huge, really large, and sometimes several kilometers long metal pipes. These are called penstocks that we discussed about earlier. And other than that, so in many dams, particularly the large ones, there are spillways. There are main spillways and there are auxiliary spillways. And I don't know if you remember, I think back in 2017, there was an auxiliary spillway failure in the Oroville Dam in California, which had led to a massive evacuation. Several hundreds and thousands of people had to be evacuated to avoid loss of lives. Here in India, a dam failure is quite common, particularly the earthen dams, which are really old. And the last that I remember is the Tiware Dam. So you could just look it up. The Tiware Dam in Maharashtra, that had collapsed. So dam breaches or collapses or spillway breaches, spillway failures are something that as civil engineers we should aim to avoid. Now, here below are two pictures that I myself had clicked when I went to this beautiful place called Bhadra in Karnataka. These are called the backwaters. So, this is the reservoir backwater, and they're lovely. So, you might have seen, if you have been to Kerala, you would, or I mean, even if you have not been to Kerala, you would have heard about the Kerala backwaters. So, those are the backwaters of the sea. But here we have something called reservoir backwater. So because you had built the reservoir, the depth of water upstream of the reservoir in the river increases, and by how much it increases and for how long. Those are the kind of questions that we will be addressing in this course. And here we have a very interesting and perhaps known to you image. So that's the campus, that's our campus of IIT Bombay, that's the Powai Lake. And this shows the main pipeline. So this elevated storage, as I was telling you, near Samir Hill, you would see a very large elevated storage tank, and there are some septic tanks which are for wastewater disposal. This elevated storage tank is for supply, and the main pipes are also shown by these thick arrows. That's the network here. If you would like to analyze uh, based on the principles of hydraulic engineering. And lastly, I'm going to show you a schematic of how you treat the water. So remember those two structures that we saw, the intake structures. If you are taking water directly from the river for water supply, then you would have to, for municipal water supply particularly, you would need to treat the water. The water may not be potable directly from the river, because you have a lot of industries discharging effluent in the river, or you have a lot of uh, pharmaceuticals, or you have fertilizer, agricultural waste products all coming into and leaching and draining into the river. So we need to treat the water. So this figure here shows a schematic of water supply treatment. Schematic of water treatment for water supply, particularly municipal water supply. So we have the screens which protect the water from very large boulders and large obstacles. Then we have several processes such as coagulation, flocculation, sedimentation, and then lastly we have filtration. And from thereafter, some disinfectant, particularly in the form of chlorine, is added, and then purified water is distributed in the system. So, although this particular aspect is included in the syllabus of the course, that is water treatment, however, this has happened because a lot of content has been crunched into this course, and literally two courses have been merged into one. So it's physically quite impossible to cover the entire story that we discussed. So water supply is something that we will be briefly touching upon, if not omitting altogether. If time permits, we'll touch upon it, but we'll not be studying it in great details. So here are the different modules. Module 1, 2, and 3 you can expect to be covered in like really great details. Module 4 we'll see depending on how much time is remaining. Here are some references. So Professor Pani's book is what we mostly will be referring to. He was a professor in IIT Bombay who retired recently, and his book is quite concise and has problems which are of the level of what do you say, aptitude which is expected in the IIT curriculum. So we'll be using Professor Pani's book for a major part of the course. For dimension analysis and revision of fluid mechanics, you can refer to Chengal and Simbala or any other textbook on fluid mechanics that you are comfortable with. For open channel flow, our main reference would be Subramania's open channel flow. Again, it's an Indian author, Indian perspective, lots of problems relevant for the Indian scenario. However, if you're interested in any other and another book on open channel flow, then I would recommend Viti Chow. This is one of the best books on flow in open channels. And if when we discuss the details on water treatment, then we'll be referring to these CPHEEO manuals. So yeah, that's what you may expect to learn. What we will not be covering, some of the topics that I wish we could have covered but will not be covering. So we'll not be covering hydraulic machines, the detailed workings of machines such as pumps, turbines, and so on. That will not be covering. Water policy issues will not be covering. Water policy and governance. So those are, again, you may actually find these courses being taught in a humanities and social sciences department, perhaps. Unfortunately, in civil engineering, at least for this course, it's quite out of scope to discuss these policies and governance issues. And one aspect which I wish would be incorporated in future is some inclusion on these social sciences perspectives, and hopefully we'll have some interesting demonstrations. So we will be including. So these are will be including some demonstrations such as HECRAS. That's for the open channel flow analysis. These are all state of the art computational packages which are used in the industry. So I just wanted you to have a flavor. So we'll have some very brief demonstrations such that you can look at these demos and then explore the packages entirely on your own. So HICRAS is something that we will perhaps be discussing about, and then on the pipe flow we may discuss about EPANET. Sorry, so that's EPA, Europe. Sorry, Environment Protection Agency of the United States. So it's US EPA, EPANET. Oops. And then on the water hammer analysis, we may look at some software such as Alivi. Closely associated with EPANET is our own IIT Bombay product called Jal Tantra, which is an sort of an water allocation come demand analysis software, which is merged with EPANET. These two platforms can be merged together. So hopefully we'll talk a little bit about Jal Tantra also. And yeah, that's pretty much it actually. So yeah, hopefully with all of this, you will have a good fundamental understanding. This is an undergrad level course, so the whole idea is to give you a fundamental understanding. So even if you are using computational packages, you should know what goes on behind them. So that should be the goal of giving you these demonstrations. So yeah, that's about the introduction to the course.